Hey, all you gooders and shooters cuts. Welcome to Unit 4, Section 3 Notes, Soil Formation and Erosion. Bad. Oh, look at the little dude. All right, so properties of soil are determined by a couple things. 1, parent material. 2, climate. 3, topography. And 4, organisms. And we're going to go into more on these, and time. We're going to go more into these in the next couple of slides. So we have these five that are going to determine the different properties of the soil. So number 1, parent material, which is where did the rock come from? So you start with unweathered rock, work your way into some weathered parent material, and then as the rocks get smaller and smaller and smaller, you get soil. So quartz is very nutrient poor, and this is what you find out on the Atlantic coast. This is where I grew up. So this is what we see a lot of out there. Calcium carbonate is more common around here. Very high calcium, high pH, great for agriculture productivity, less good for kidney stones. Areas with lots of calcium carbonate that tends to get into the water and then into your body, and those areas tend to have higher rates of kidney stones. So there you go. Second thing is climate. So you can have issues like it's too cold, and then like permafrost, permanently frozen ground found in the tundra. This is too much undecomposed organic material is found there. Or something like, let's move me down, humid tropics, the rapid weathering of everything, the leaching of nutrients and the decomposition of organic detritus. So the soils in this area is often very poor. All the nutrients are in the plants themselves, which we've talked about before. Then we have topography. At the top of an area, you're going to be really well drained. And then as you go down, you tend to be less and less. I'm going to move me up here so you can see a well-drained area is going to have really nice soil. And then you're going to have kind of some different rocks and soil depending on how drained it is. So depending on the slope and arrangement of the landscape and the amount of erosion, depth of soil, you often can get like some really good stuff down here, or it doesn't break down and then you get that peatiness. Organisms, the critters. So 1, plants are in soil, which will help with both nutrient removal and they excrete acids. So they're taking nutrients from and they're putting acids in, and both are bad. Animals help with things like tunneling and burrowing. Earthworms, gophers, voles. So sorry. And this is going to help make places for the air to go, for water to go, for roots to go. And then all organisms are going to help with cycling of nutrients. Fungi, bacteria, all of the above are going to help with that. And then we also have a definite impact on the soil. Time is the same as, we'll move me down here, same as above. So you have your bedrock, and then you have parent material, and you're breaking down the rock into smaller and smaller pieces. You add that organic matter on top, whether it be dead stuff or poop, or a combination of both, and then you eventually get all of these things. But this takes time. All right, moving on. Back over here. So anthropogenic soil degradation, which means humans are making soil bad. One of the reasons we do this is we plow our topsoil a lot and then remove it, which is obviously going to increase erosion. Excuse me. All right, so plowing is actually awful for the soil. It causes a lot of erosion, so they're doing a lot of low or no plow farming now to try to reduce that topsoil erosion. We also, we'll move me to the middle, compact the soil, crazy a lot. Either by machines, by humans, by livestock. It's going to cause a lot of drying of the soil. So water isn't going to circulate because it's compacted too much. It's not going to be able to get in, which means it's going to get waterlogged and the water will stay on the top layer, and therefore the oxygen isn't going to circulate and get down. And then it's also more physical, mechanical resistance to root development. So it's going to be harder for the roots to go down into these areas that have been super compacted by humans. So what happens is you have less in these compacted areas. You'll have less vegetation, which is going to cause more erosion. Less vegetation means less roots in the soil, which means more erosion, more soil can get washed away with water or blown away by the wind. So we have, up here, we have decreasing vegetation, which is going to lead to erosion and nutrient loss, which is going to cause more vegetation to die, which is going to lead to more nutrient loss and erosion, and on and on and on. Do you guys remember what kind of feedback loop that is? We're continuing to go in the same direction, so that would be a positive feedback loop. All right, traditional agriculture, we'll put me here. Traditional agriculture is your industrialized agriculture, and we are crazy depleting the soil of its nutrients. In the last 70 years, we have crazy reduced the average mineral content of fruits and vegetables. If it's not in the soil, it can't go into the food. So literally just the fruits and vegetables that we're eating today are not as good as the fruits and vegetables that they were eating 50, 60, 70 years ago, which is kind of crazy. So we need to really work on getting those nutrients back into the soil. So if you're buying from, say, a farmer's market or more organic places, they might have actually bothered to put some of those things back into the soil so you're eating a more nutritious piece of food. Pesticides result in chemical pollution. If you need to wear a mask to put this on what you're using, maybe it's not the best thing for it. Just throwing that out there. All right, here is a visual of soil degradation over the world where it's very degraded or somewhat degraded. You can see most of the cooler areas tend to have stable soil, but then it's also, you can't grow stuff up there as well. And then we have areas without vegetation, either ice or desert for the most part. And then let's move me back down here, properties of soil. So the physical properties are the size and the weight of the soil. So sand is bigger than silt, is bigger than clay. So sand is about 2 millimeters to 0.05 millimeters. Silt is 0.05 to 0.002 millimeters. And then clay is itty bitty. Think of the sand you see on the beach and how tiny that is. And then these guys are even smaller. So you're not going to have to probably not need to know the actual millimeters of these things, but I would know that sand is bigger than silt, is bigger than clay. That is definitely something you should know. Permeability. Once again, sand is more permeable than silt, is more permeable than clay. And this is how quickly water can go through it. Move me here. So if I have a meter of gravel, sand, silt, and clay, and I dump water on top, it will take 2 minutes for that to go, the water to go through the gravel. Take about 2 hours for the water to go through the sand. It will take 200 days for that water to go through the silt, and 200 years for that water to go through the clay. So it definitely takes a long, long time. Clay is not very permeable, which comes into handy for stuff I will talk about in a second. Porosity. There's no good place to put me. We'll put me here. It's the percent space in the soil sample. So the more pore spaces you have, the more porosity you have. It's kind of hard to classify things this way because sometimes you have low porosity and low permeability, and sometimes you have high porosity and low permeability. You can have all of the combinations. So you can have large spaces and high porosity or small spaces and low porosity. So understanding what porosity is important, but it's harder to group the different soils this way. Most landfills are lined with clay because if you remember, it takes 200 years for water to go through clay. So if you have this nice clay liner, and then sometimes some other things, and then original clay, anything that is going to drip out of this landfill is going to get caught by this clay liner, at least for the next 200 years. So, and then they do a final cover over top and usually build like a golf course or a park over top of these things. The other thing they do is they'll take plastic. So there's clay underneath this, then there's a plastic line, then there are tires, old tires. So this is one way to recycle things one last time. And then the landfill goes there. There's a greater risk of groundwater contamination when you're dominated by sandy soils because that permeability is so great. In a sandy soil, the water's just going to go through it. So any place where there's sandy areas, you need to really make sure you're not polluting in those areas, because that's going to get down into that groundwater really quickly, and you can't fix groundwater once it's contaminated. You just have to not contaminate it. Move me back down here. So this I thought was really cool. So protecting Treasure Island. So sand and other soils like that tend to do what is called liquefaction, which is the soil gets so weak it actually flows and behaves like a liquid, which can happen after, say, an earthquake. So what they do is they lower this little torpedo-shaped vibrating steel device, and so they kind of hollow out an area with high pressure water. They dump gravel in and like bash it down, and they essentially turn it into like a stone column. And this stone column is going to help support all of this. So in the event of an earthquake, it's not going to liquefaction, and go away. It will stay where it's supposed to. So it's really neat what people have come up with to prevent problems. So when you're watering your yard, you need to know what kind of soil you have. Here in Indiana, we have a very clay-heavy soil, so it holds a lot more water, but it's much slower to absorb that water. Sandy is very porous, which allows for quick water flow. So if you notice, sometimes people overwater their yards in Indiana, and then there's just too much water on the top. So you need to kind of do like small amounts often, versus sand where you can just soak it for a while and then it'll just be down in there. Loam is the optimal soil type, and you just water that normally. So once again, you need to make sure you have to water it enough. So in dry times, the plant has enough water, but if you water it too much, then the plant can get waterlogged, and then it's not getting oxygen where it needs to. So we have a couple properties of soil, and one of them is chemical. So the first one is cation exchange capacity. The main thing you need to understand for this is the higher the CEC is, the more nutrients it can hold, and therefore the better the soil is. So if you understand just that concept, high CEC, good for nutrient holding, good for the soil. Two main things make this happen. One, a greater surface area, and this goes on your packet, a lot of negative charge and a lot of surface area is going to cause that to have that higher CEC, which will make it more able to hold those nutrients and therefore healthier soil. There's a video I will post in Canvas. We're not going to watch it now. Come on, next. Then the second one is called base saturation. So once again, you don't need to know all the super nitty-gritty details of this, but understand that the more basic the soil is, the better nutrients it can hold, and the healthier the soil is. So you want high CEC and you want a higher pH. The more acidic the soil gets, the less nutrients it can hold, and that is bad. So basic soil, or more basic. The best agricultural soil, the best soil to grow food in, is a mixture of sand, silt, and clay called loam, plus a nice little mixture of organic material. It allows water to flow through nicely. It doesn't get waterlogged as much. It's just a nice, happy grouping of all of the kinds of soil. The person who I got this from is in San Francisco. So they have these gorgeous nutrient-holding clays, which has a decent amount of silt and sand. So they have very fertile loam out there. We have much more of a clay soil out here in Indiana. The water just kind of stays on top, and it's hard to grow stuff in it. Here's that from a while ago. Once again, talking about the fertile soils in San Francisco. All right, on to properties of soil biological, which I kind of touched on before too. So the fungi, bacteria, and protozoans are making up about 80 to 90% of your little critters, and these are going to help with the decomposition of all the little detritus that's out there. Your rodents, earthworms, snails, slugs, your detrivores are going to help mix and break down the material. So they start the breakdown, and then the fungi, bacteria, and protozoans finish them up. And then you have nitrogen-fixing bacteria, which is going to fix that nitrogen in the nitrogen cycle so it can go into the plants and then into us. and all of those fun and exciting things. And you have finished. So before we go, I want to let each and every one of you know that you are good enough, you are smart enough, and people do like you. And in case I don't see you, good afternoon, good evening, and good God, do your homework.